Alright, here we go. Essential question as you see. How do you find the domain of a function? And in this section, you're going to be asked to do one more thing, and that is to find the domain of those particular functions or that particular function. So let's talk about what domain is real quick so you get the idea. Just remember, because we did talk a little bit about it before. By definition, here's the domain. It is the set. So it's a whole bunch of numbers. It's a set of numbers. Could just be one. Could be none. It's a set of a whole bunch of numbers of all the input values for which a function is actually defined. And we'll talk about what that whole thing means here in a little bit. So, if you remember, here's our function machine. Here's our mapping diagram. Function machine, remember, we input an x value into the top of this function machine. We called that the domain. It was all of the inputs. And then this particular rule right here that I have inserted into the function machine, this is my f of x function. I have square root of x, so that's my rule that I'm taking my inputs and I'm doing this rule to it, and I'm going to output the y value, or the f of x, same thing, and that's called the range. So the domain is all of the stuff that you put into this function. Now here's the trick though. You can't just throw everything into the function. Well, I guess you could, but the domain is only the input values for which the function is defined. I'll change it this way for you. The domain is all of the values that you can put into this function that the function machine actually says, I like this, I can do something with it, I got no problem with it, and it will output a particular number. So here's an example. The function f of x is this function square root of x. Very simple one. So, one example, if I have the value of the function of 4, that means I'm going to put 4 into the top of this function. So I put 4 in for x right here, like that. So I just simply do the square root of 4, and it gives you a 2. So you're putting a 4 in for here as a domain value, a potential domain value, and the input of x gets the rule of square root of x, and when you square root 4, it outputs a 2. All is well. Another example, how about f of 8? Well, if I put 8 in here, it's totally fine because the square root of 8 is certainly legit. You can punch in your calculator and get a decimal, or you can reduce it by taking 8 and break it up into a perfect square and a non-perfect square. That 4, remember, square root of 4 goes to a 2, and then the square root of 2 is not perfect at all, so it just stays square root of 2, and that is your answer. So that's perfect. No problem. So now, let's get to this example. You see the value of the function f of negative 9. Well, if I put negative 9 in for this function, you put a negative 9 in there for x, here's what it gives you. The square root of negative 9. And if you would punch that into your calculator, it would say, problem, issue, massive issue, because you cannot take the square root of a negative number. That is a problem. So, this would, as I just told you, it would give you a massive error message, or domain error, or syntax error, depends on your calculator. It gives you an error message. That means this in general. We'll get more in depth in this. That means negative 9 is an input value that would not work. It would actually blow up your function machine. That's no good. So, over here I just gave you a simple another idea with the mapping diagram. You're taking an x and mapping it to y. Input goes to an output. So for example, we did 4 and that got mapped to a 2 with this particular function, just as a reiteration. So, let's talk a little bit excuse me, more in depth about this. Now here's kind of the way that I would think about it. The question really you want to ask yourself when we're talking about domain is, what can I, or you, throw into this function machine that does not give me an error message? So I have the analogy up here of a truck. It's a beautiful truck, and you see this little thing pointing to that gas cap right there, I guess. So what things could you put into a truck that wouldn't give you an error message? Well, the only thing that you can put into a truck, into that particular spot right there, would be gasoline. Doesn't matter the octane level, really, although some cars require the higher octane level, but you have to put gasoline in it. If you put oil into that particular spot, that is no good. If you put water into it, if you put soda into it, if you put, I don't know, M&M's into it, that doesn't make any sense, but whatever. So there's certain things that you cannot put into the gas tank, into a car or truck, and it work. You have to put gasoline in there. So the idea is, what can I put into these functions to make it work? If it doesn't work, that cannot be in my domain, because it cannot be a possible input value, because it won't give you an output value. That's why. So here's the idea. Function machine, I just told you this, square root of x. That was one we just did. What can I throw into this function machine to make this function machine not say, error? Well, I can throw everything into this function machine. In fact, all of the real numbers I can throw into this function machine. By the way, I should tell you this. That's what this stands for. That symbol right there stands for all real numbers. So everything, all the number line, all the decimals, irrational, rational, all that stuff. So you can throw anything into this function machine except anything that's negative. Because remember, if we put a negative into this function machine, it's going to output wrong O. Wrong O, can't do it. So as you notice, here is the actual domain for this function. The exact answer that you put. It's all of the real numbers that are strictly greater than or equal to 0. Because it could be equal to 0, because if you put 0 into this function machine, the square root of 0 is 0. It works. So that is the actual domain for it. Now, you might be asking yourself, real numbers. That is, there's an infinite number of real numbers. How in the world am I ever going to pick out the numbers that I can't use of all the infinite numbers that's out there? That does seem absurd. Well, there's two scenarios that actually is going to help you do that. So let me slide this across here, and you'll see there's two situations, scenarios, whatever, that would give you an error message. And these are the two that you need to. Now, I put this in green as another way maybe to think about it. And here's the idea. If neither of these two situations are evident, and you'll see what they are here, then the domain is always going to be all real numbers. Well, I shouldn't say it. No, in this situation, it will be. So if neither of these two scenarios happen, all real numbers, then that would be your answer, all real numbers. So here's the two scenarios. Scenario number one, if you're dividing by 0, that's the first thing you got to look for. If you're given a question that says, what's a domain? Automatically look for if you're dividing by 0. If there's any situation where you're going to be dividing by 0, caution. Caution, red flags, lights should be flashing. You should be, whoa, 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 I need to check for this. So if you notice this first example, this f of x function, I have 2x to the negative 1 power. You might look at that and say, well, that doesn't indicate to me anything divided by 0. Be careful, little ones, because a negative exponent means I must put that down here. And remember, the only thing that's being raised to the negative 1 power is just the x. That's why the x is down there and not the 2. So take a look. Uh-oh, I have a situation where I could be dividing by 0. So I could put anything in for x, anything into this function, any real number, except I cannot put 0 in there, because if I put 0 in there, guess what? I have 2 divided by 0, and that is no good. So my domain for this function, what's all the numbers I can put into it? That won't give me an error message. All real numbers, except, this is it, except 0. That's my domain. It would be all the real numbers except that. So here's scenario number 2, or example number 2. You see this situation. Whoa, I have a division, so I'm probably thinking about dividing by 0. And this is a different one because notice, it's x squared minus 1. Well, what you have to ask yourself is, since I have a denominator, what would I be able to put in for 1 here that would make that denominator 0? Because then that would give you a scenario like this, of which you can't have, and you don't want it. So you have to do a little bit of work with this one. That means this expression, the denominator, you do not want it equal to 0. So let's find out what you would put in for x to make it 0. Now you can kind of maybe guess and check if you want to, but let's do it algebraically. Let's say, well, there's my denominator. Let's find out what would make this thing 0. Well, let's just set it equal to 0. And what we've just created is a simple little equation. So let's solve it. Well, you'd add 1 to both sides, which would give you that. You take the square root of both sides, phenomenal, which actually would give you x equals 1. If you think that's the answer, you're almost right. Don't forget, it is always, when you take the square root of both sides, it is plus or minus, plus or minus, plus or minus. So there actually is 2 numbers here that would give you an issue, a positive 1 or negative 1. If you put a positive 1 in there, that would be 1 minus 1, which would give you 0. Error, can't do that. If you put a negative 1 in there, negative 1 squared is 1. minus that one would give you 0. Bingo. So there's the problem. So what's my domain? Well, it's all real numbers except 1 or -1. Other than that, my friends, it's good to go for a domain. So let's go on. That's scenario number 1, dividing by 0. Scenario number 2 is this. If you ever see a radical and it happens to be an even root, so a square root, a 6th root, a 4th root, a 20th root, that's ridiculous, but it could happen. So an even root, if you see that, if it's an odd root, doesn't matter. If it's an even root of a negative number, that is an error message, again, because we talked about this at the very beginning of this video. That's the function that we had. Remember, you can't put anything in that's negative. So my domain for this simple one will be, well, this thing right here cannot be anything less than 0. It could be 0. So that's the situation. So that can't happen. So my domain would be all real numbers, as you saw before, that is bigger than or equal to 0. Anything that's bigger than and or equal to 0. So there's your 2 scenarios that you really have to worry with. And remember, if it's none of those 2 scenarios, it's all real numbers.